How are you doing? Sorry, I'm like 1 minute late. I just got to the campus. Okay, so I think we have a holiday coming up on Monday. Let me double check here. That will be for your Labor Day. So there will not be class. If you have classes with me on Monday and Wednesday. So you can also find that information on the academic calendar. Let me go into screen share here. Okay. And this is on either MVC or you can also use RCC website. So let's see, September 6th. Oh, that's not till later. So yeah, that will be Monday. So you will not have class on Monday. And then we will do one activity on the Wednesday. And so we have a shorter week next week. So I just want you to remind you that there will not be class session on September 6th, which is Monday. Okay. All right. So I know some of you are running into issues with the Windows aspect. I received some emails, so I'd like to address that later, as each of you might have different scenario on how that would be. So let's touch on what we need to do today first, and then we will go through the process. So today's lab is going to require Linux, and this is going to be an activity on memory profiling and KCacheGrind. Now, if you're using Ubuntu, Ubuntu is fine, but you need to install KDE only because the programs are written for KDE. Now, if you don't have Ubuntu, you can download the zip folder here that I created. And this zip folder contained the virtual machine that I made. And it already have KDE. It has KDE desktop install. So by default, when you use Ubuntu from the download from Ubuntu website, then you would find that it uses GNOME desktop. And if you want to use other desktop, you have to install other desktop. Now, the applications that we are using, like KCacheGrind with another tool, it uses KDE, so it's important that we have the KDE desktop install. Now, you don't have to use Ubuntu if you're using a Debian release like Kali or even Raspberry Pi. Some Raspberry Pi, if you have enough RAM, you can put the KDE desktop, do the installation, and you need to read the documentation for that. Another version that recently got released is called KUbuntu. I started writing instructions for this, and I created a virtual machine running from my flash drive using KUbuntu. This is a full version desktop, and it has development tools. However, it takes a long time to install. So if you choose to use this, so basically this is a Focal Fossa, which is also a Ubuntu release. All it is it's just come equipped with additional features on the desktop. You can also obtain the ISO and look at how you can go through the process for creating the installation. It's very close. So with that said, coming back to our assignment, if you don't have Ubuntu virtual machine, then I can show you how you can do that. And I uploaded this onto my Google Drive, which I have a lot of storage. So roughly you are looking at about, when it's zipped, it's about 3 gigs. So it depends on your connection. That might take a while to download or fast. And then if you want to make the virtual machine, I did write the instructions, which is part A and part B. So I can briefly describe what that would be like. You can run it straight from a USB flash drive. However, when you move any kind of file that's larger than 4 gigs into USB drives, external hard drive, USB flash drive, you need to format that drive as NTFS. It cannot work with FAT because FAT allocation for the storage is the limit is about 4 gig. So all USB flash drive comes formatted as FAT, file allocation table, because that file system works with all platform. So if you have a brand new USB and you want to use it for virtual machine, you can format it as NTFS, and then you can copy, you can copy virtual machine back and forth. Otherwise, it will not let you move anything larger than 4 gigs, especially on the Windows side anyway. Okay. Any question? So let me get the files going here. For the lab, there are options for you to use. If you're using my virtual machine that I created, the username for it is student and the password is CIS30E as it's typed. Okay. So I'm going to run through real quick. I know some of you already had me for other classes. You already know how to make virtual machines, but for those of you who hadn't done this before, now Ubuntu has an option to use multipass, and you can use multipass to be able to control your virtual machine. It's an application that you would use to be able to manage, open, control your virtual machine. The freeware that we're going to be using, the open source type of tool that we're going to be using is Virtualbox. So whether you make the virtual machine or you download the one I created, you have to install Virtualbox, which is part A. Okay. And VBox is commonly used in the industry. It's made by Oracle. It's used, virtual machines are used for testing purposes and even running infrastructure. As far as cloud, you can see EC2 on AWS, Azure, and so on. So VMs are very common, and there are a lot of different tools that you can use to create VM. So the one I chose, Virtualbox, is mainly because it is cross-platform. You're able to use it on the Windows, Linux, and also on Mac OS. If you're using VMware, the files are different, so you cannot create virtual machine in Virtualbox and run it on VMware. You can using the VDI and conversion, but likely that it will give some kind of warning or error. So the link that you would need is here. You would need to install Virtualbox. And with that, you just keep all the default configuration and you would be able to run the application and open up your virtual machine. So for KUbuntu, Ubuntu with KDE desktop, the ISO that I chose to use, so I did 2 iterations. One is I install it with regular Ubuntu Genome desktop, and then I finish and then I install the KDE, which I found to be faster than installing KUbuntu right off the bat. The ISO for KUbuntu is larger. The installation process is much longer. Yesterday it took, I tested it yesterday and it took about 2.5 hours to finish install on my flash drive. So I don't want you to wait that long, but if you want the experience, you can try it. So once you visit the site, it will download the ISO, which you see here. And this ISO is an image file. You can use it to create your virtual machine. Okay, so I'm going over part B now. Then After you downloaded the ISO file by clicking that link, then after you install part A, which is VirtualBox, you are going to open it up by typing in VirtualBox, and I'm using Windows system. So here I would see Oracle VirtualBox. I would open that up. And now if you wanted to make a new virtual machine, you would start here. And this is important, this screen right here, because if you type in the virtual machine or select the virtual machine, so let's say I put Ubuntu, right? It automatically select these options for me here, okay? And then it's gonna put it into the default location, which is C user, your username, VirtualBox, and VM. So if you wanted to put it into a flash drive, this is when you would browse. Okay, so you would click the drop down and then choose other, and then you can put it, into a folder of your choice. So let's say that I put it onto another drive, like my data drive. I would then I should make a new folder for it. Okay, let's say like this, and then I can say Ubuntu VM lab or something like that. And then make sure that you select that folder. Okay. So now it's going to know where to write your virtual machine to. And then after that, you're going to go next. Now the default is going to be 1 gig of RAM. You want to go higher than 1 gig, because if the lower the RAM, the slower the virtual machine would be. Virtual machine mostly uses hard drive and RAM. So most of the time it simulates another system as inside your host system using RAM. So I recommend doing about 2 gigs. So if you have a computer that's 8 gig, 2 gig is safe. So you would do 2048 megabyte there. Now, if you have a 4 gig system, you are gonna be, so in that case, you should dedicate only a gig. So both your OS and your virtual machine will be slightly slow. OS will take up about close to 4 gig of RAM, and the virtual machine operating system, it's gonna need at least 512 to a gig in order to run at bare minimal. Now, the least RAM that you give it, the less amount of application that you can put on your virtual machine. So that's important to keep in mind. So I would say 2 gigs is good. On a system that you have more RAM, like 32 gig, you can give it 4 gig if you want it a little faster. But I think 2 gig is good. Question? So then you just tell it to create a virtual disk, right? And it's going to write the VDI, which is the file that virtual machine is needed. Now on the VMware, which is another product that's used to create and open virtual machines, it uses VMDK. So in that case, if you wanted to be versatile for other products, you would choose this option or the VHD for the virtual hard disk, where you have to mount the disk. Then I usually tell it to dynamically allocate it so it writes faster. But if you wanted to choose fixed size, then you can set it up to be a fixed size. So what happens is it's going to cut up the storage to a certain size virtually, which is 10 gigs. And it's going to write in between those 10 gigs anywhere on your drive. Now, if you do it fixed size, it's going to write more sequentially, and it's going to organize it to a certain area of your disk. That will be okay if you wanted to keep the organization and the allocation of your disk, but eventually it's going to be a little slower. Okay. So this is where you would want to point to earlier we chose the location of our drive, and this is where it's going to show that again. Now, if you have a lot of space on your hard drive, you can give it a little bit more than 10 gigs. I would say 20 gigs. Okay, 20 gigs are generally safe, but if you only have a flash drive that's 16 gig, so virtually if it's about 10 gig, it's gonna physically, realistically run like 60% of that. So we can go ahead and click create, and that is where we would then, it's gonna put that over here, okay? Now, it's not gonna go anywhere until you tell it to start. And then once you have it started, then it's, you can finish the installation by mounting your ISO. And the ISO has the root files that it needs to install. So, for those of you who have challenges with the Windows exercise in the assignment, you can also use a virtual machine to be able to do that. You have any question? All right, so the instructions is pretty straightforward. I typed down all the steps for you. So after you tell it to start, you're gonna navigate to the ISO file that you downloaded, and then that will be on in your downloads folder. And then you just click start, and then you are going to install. And it's generally gonna install after you set up like the time zone and all of the basic configuration. And then you're going to enter your username and password. The process can generally take about 15 minutes. Okay. All right. Now, if you download it from my Google Drive, I think I deleted it, you would have a zip folder, something like this. Let me go to my drive. Something like this. Okay. So once you download it, you're going to get a zip folder. It says Ubuntu on it. I don't know what kind of software you have to decompress your file. If you use the default operating system one, you just simply right click and you should be able to, it should show like extract all or decompress. You can also use a third-party tool like 7-Zip or WinRAR, things like that. So I'm using 7-Zip, and I simply right click the compress, and then I extract it. So I just tell it to extract files. And once it does that, it's going to take a few minutes, and you're going to have another folder called Ubuntu like this. Okay. So if you open it, you're going to see a subfolder called Ubuntu. Here's your VDI file. It needs that to run your virtual machine, and then it creates other files. And the logs, whenever you use it, it's going to note that. Okay. So how do you open it? You can double click it and choose the application, but VBox, the way that you use it is you open up Virtualbox. Okay. Then Virtualbox is going to look like this. Then you are going to click the drop down arrow next to the green button. Sorry. I'm in the virtual machine now. And then it tells you that you need to open it. So you would need to click add. Once you click that drop down arrow, you're going to see an add button. And then you just need to browse to the location of the decompressed, the extracted folder after you extracted it from the download. And you would locate the VDI file. It would say .vdi on there. And that's how you're going to be able to launch. Okay. And it's going to look like this. So it looks slightly different than your typical Ubuntu because it has a different desktop. And this is a Plasma desktop with KDE. You can always switch back and forth, right? Ubuntu on Wayland, regular Ubuntu, or Plasma. So after you use this and you don't like it, you can change it by clicking the arrow button right here, and that allows you to change the desktop. So it's gonna look different than what you've seen. So I'm gonna go ahead and log in here. And so here is, let me turn off the video just in case it's not, I'm on the school network, so generally bandwidth is pretty good. Okay. So what it's gonna do is gonna load your desktop like this, and you're not gonna have a lot of things in the middle of the desktop like what you've seen in other type of desktop for Linux releases. Think of this as a start button, and they use this, it's called application launcher. You simply click that. If you wanted to find anything, everything is searchable. So now the terminal is going to be called console, but you can still search for it. So let's say if I search terminal, right, it's going to locate that there. And then if you need like files or something like that, you will still be able to find file manager. So unlike the regular Ubuntu desktop, you see the KDE desktop is a little different, and this is Plasma. There are other iteration of it that looks different than this, right? And it has LibreOffice, that's equivalent to OpenOffice, or very close to what you see with Google Docs. Google actually took a lot of the core from Libre and OpenOffice. And then your system settings or anything like that, you can see that there. Your file manager is called Dolphin. So the theme of the Plasma desktop is the ocean. And so as you can see, right? So a lot of the things that they name in here is going to be relevant to the theme of the actual desktop. Okay. So just a brief run through for the Linux side. All right. Any question? Okay. So I had put down the instruction for those of you who need to install the KUbuntu desktop or the Plasma KDE. All you have to do is open up your terminal, and then you're going to run a couple commands. And it's going to ask you if you wanted to download and install. You have to tell it yes, and then it's going to do its thing. And when it's done, it's going to ask you to reboot, or you should reboot after. So the command for that is simply reboot. But the important thing that you need is the SDDM, which is the second choice when it does the installation. Otherwise, you're not going to have the full Plasma. Then you have to go back and reconfigure it. All you have to do is reinstall it again, and then run the prompt, and then select the option with your keyboard. Okay. All right.
Question.
Yeah.
What is there a security risk, which is why we're doing a VM rather than its direct download?
No. The virtual machine that I put for the download is the one I just created. I give you two options for those students who want to learn how to do it. They can learn how to do it. It's important because, you know, one way or another, some class is going to ask for some kind of virtual machine. And then, you know, but if you don't want to do it, then you can download the virtual machine that I created, which, you know, is the same.
Oh, no, I mean, you use an actual Ubuntu laptop instead of a Ubuntu.
Oh, yeah. Okay, so the benefit side of using the virtual machine compared to an actual system, right, is that, you know, you can always, if you messed up, you can always delete and recreate instead of installing the whole system, right? From my perspective. And so you can run a lot of things. But virtual machines are very limited to its size and RAM and all of that. And it's still run, you have to have a decent amount of system resource to really run it on the host. If you have the capability to install it on your desktop or on your laptop, I think it's great. I think it's good to use Linux and be able to run that. So you're not limited to the RAM and stuff like that. So after I created this, at the end, you're going to see that when you add a lot of tools, it's going to run out of storage and it's going to run out of RAM. So you can actually expand it if you want. But in the case where if you have a lot of application, virtual machines, sometimes it's going to be limited. Okay. So I don't really, security wise, it's really up to you, in my opinion. There are attacks that can go from virtual machine to the host systems now, right? Compared to before, there was not, but now there are attacks that are like that. So it's good for testing. And you can make a lot of different virtual machines instead of doing dual boot, right? Because it's really depend on how you format your file on your hard drive, on how many how many partitions you're going to be able to use. Like that means how many operating system you're going to be limited to. So there's some limitation on the actual physical system, if you're running Linux that way. Okay. But there's so many, I start reading a lot. I start using multipass. It's really interesting. So you want to keep up with the technology. So the type of jobs that you're going to run into, if they ask about it, you would know, and that gives you leverage. Okay. So once you have your virtual machine running, we are going to, you can start at part C. Okay. And part C, this lab is really focused on the tools that we haven't touched on in the assignment. So this is going to give you the experience in memory line-by-line profiling, and you can run this for any of the Python applications that you've previously written. So the memory profiler is really a module. It's the Python file that's written to assess the memory consumption for each of the functions. And what it's going to do is going to utilize a line-by-line analysis, and it's going to give you an overall understanding of how your application is using RAM. We talked about how resource allocation is important when we're designing our application. So if you started with the first version of your application and you're happy because it's working, what you want to do is you want to utilize the profilers to really see, how the resources that's using and what can you do to improve. And then the next version, you can do the same thing. Okay. So I wrote the step using their documentation. So you can get everything from the documentation. Okay. Because the book is fine. I think the book cut out some of the steps. So it's best whenever you're using Python tools, go and read their documentation. They're very clear about how to install, right? Most part, how to write an example program. This is the one that we're doing. And then how to run it. And then what other tools that you can use with it, and so on. Okay. So this is memory profiler. All right. So in your Ubuntu virtual machine, you're going to click that round button on the bottom left, and you're going to search for terminal, and you're going to find console. And console simply is a command line, right? And it is terminal. So you would be able to issue the command. So Linux, the way we use Linux is you know, on the graphical user interface side, yes, there are functionality of it, but if you are familiar with the command line, you're going to go farther. Okay. So, and I harp about this in Raspberry Pi and all the Linux class I teach. Whenever you use Linux and Linux systems, it's always good to do updates to start. Even when you just install it, or you know, you just did that earlier this week. So we would start with the sudo app update, and sudo app update would allow the system to go and find updated, you know, resources like, you know, versions of the software that it's using, and so on. And then in the upgrade, sometimes you would have applications and firmware that needs upgrade. So you would then also run that. Now, all Linux systems now, when you create or when you install, it's going to ask you to create an account. And with that account, you are not a root account. So root in Linux is equivalent to administrator in Windows. So when you issue the sudo, that means super user do, and that is an elevated privilege. So you need to be able to do that. Otherwise, you're limited to the user permissions and privileges when you're utilizing resources on Linux. Okay. So this is why it's going to ask you for a password. It's because you're on as student user, and student user is not a root user. So it's going to prompt that. It's always good to also check version of your software. And even if you install it, and I think a few of you have challenges with the assignment is because your system path is not linked, even if you install it. So you can find a version of something by doing -v or -version, and it would give you that. So let's try that. Okay. Now, the new Ubuntu with the KDE desktop, KUbuntu, and the Ubuntu 20.x, they are shipped with Python 3. The earlier versions, if you're using like version 16 or 14 or 17, they come equipped with 2, and then you have to install 3. All Mac OS comes with Python 2, right? And I think the new Mac OS, it's also shipped with Python 3. So here I just simply open up my terminal, which is console. And sorry, my Windows is kind of small because that's how virtual machine is. I can expand it, but I want you to be able to see the instruction here. So let me see if I can change the settings to make the font a little bigger. Should be in here. Let's see if I can make a new profile with an appearance. Okay. Choose. Let's go with maybe 16. Okay. So you can modify profile this way. That is just in settings, and you can make different profile on how you want your terminal to look. I think in general, the Debian releases are mostly the same. All right. So if we do sudo apt update, that is going to push the update. It's going to prompt us with the password, and our password is CIS30E. If you're using the virtual machine that I created. So this might take like a minute or two for it to go. So it's reading the packages and it's pulling it down and it's telling me now it's good. So we're gonna do sudo apt and -y upgrade, because in upgrade sometimes it asks you yes or no. So if you put in the option Y already, you don't have to answer it. Oh, I had a typo. It's been one of those days. All right. All right, so it's fully upgraded, and then we can check our Python version, Python 3-v. And so how do I know which version it's using? It says that right here. Okay, so on the newer Ubuntu, like I said, it's shipped with version 3.x. And then it brought me to Python. So I'm going to go ahead and give it an exit function to get out and come back to my terminal. And you know that Linux have development packages. I think down the line, or if you read some of the documentation, you can install development packages. If you install the KUbuntu using the KUbuntu ISO, it's a nice one. When it's full and it has a lot of like the features that you can use. You know, it has Qt library, which you can use to develop 2D and 3D and things like that. So I highly recommend using Linux and be familiar with it when you write your application. And there are built-in IDE in some of these too when you install the development packages. All right, so next we are going to install our pip. So you are going to do sudo apt install -y python 3 -pip, and I'm on step 2 of part C. Okay. And pip allows us to install things, tools for Python. And, you know, there are differences between pip and pip3 and Python 3. Keep in mind that some of the operating system comes with Python 2.7. So if you just use Python, it's going to revert to the default Python version that's linked to your system path. So if you don't link the Python 3 to your system path, it will automatically default to version 2.7, and some of the tools might not work across the different version of your language. Okay. So, and then I added step 3 is where you can add development tools. So we would do sudo apt install, yes, build essential library SSL dev library FFI dev and Python 3 dev. Okay, since I already installed it, it shows that it's already met the criteria and it's at the newest version. So yours might take a little bit. It's going to show the bars that's installing it. And development tools, you can look a little bit closer when you have some time on what that would consist of, what kind of features does it have, and so on. But for now, we're just going to go ahead and use the Python environment. So for step 4, we are going to make a directory called environment. Yeah, it's already exists, sorry. So I'll just do this. So you can name your working directory as anything that would be, you know, so it would reference your project. And then we are going to go ahead and install the virtual environment. Sudo apt install Python 3.8 venv. Is it not liking that? Let's try. Yeah, so try, I'm sorry, I had a typo there. It should be sudo apt-get. Okay, so we would do a sudo apt-get install Python 3.8 env. So what does that mean? It means it's going to download and install it for you. So once you have the virtual environment installed, then you can use it. Then we would do Python 3 -m venv, and the virtual environment, the subfolder folder now is going to be my env. Did I skip a step there? Oh yeah, I did. Sorry, you guys. I didn't cd in. There you go. So after you move into that folder, then you can do step 7. And this will take about a minute for it to create the virtual environment in my folder called environments or environment 1. And in that, it will create a subfolder called my env. And when you use Python 3-m, what that is just create the environment for Python 3. And the way that you activate it in Linux is you are going to use a source command. And you would do a my-env -bin. That's where your Python would be, and you would activate. So just like the Windows side, it's going to put the Python packages inside the bin folder that's going to be located in my env and under environments or environment 1 in my case. So once you activate it, similar to Windows, you're going to see the parentheses for your environment, the directory there, and that's ready. So now we have activated our virtual environment for Python. Then we can, I see a chat question. The file crashed. I had started the Virtualbox part over when we have located 2004 desktop ISO. Would that be the virtual machine definition type Ubuntu file or the VDK file? I'm using the zip file from the Google Drive. Yeah, so when you open your Virtualbox up like this, right, you go to here and then you click add. You are going to navigate to the VDI file in the decompress or the unzip folder called Ubuntu. Right after you download it, you decompress it, and then you simply just find that, not the ISO, because the ISO is used to create it. So if you're doing like the end of part, if you wanted to go into part C right away and you downloaded it, you are going to just simply click here, click the plus button, and then navigate to the decompress file. You cannot leave, it will not allow you to use it if it's zipped. So you have to unzip it and then find the VDI file. Okay. All right. Other questions before we come back to the virtual environment? Okay, so the next step that we need to do after we activated our virtual environment, which is step 8, then we are going to install the tool that we need. Okay, so once you activate it, you wanted to bring in all the tools that you need, and you can use that Python virtual environment to test out your script. Okay, so we are going to do a pip3 install -u memory _ profiler. So now we are going to install this tool. And once it's installing successfully, it'll say successfully installed, right? The current version, which is 0.58.0, and it will bring in the ps-util, as you would see that in their documentation. So Linux is very simple. I love it for the fact that installation, if you're pulling stuff that's from Git, it's so easy. And you can download stuff from website using curl or wget, or I call it wget, but it's wget. And so there are different commands that you can use. So you don't have to click 5 times in order to do something. It will pull all the stuff down for you. Windows similarly, right? But a lot of these tools are written for Linux, so you don't have a lot of support on the Windows side. So you kind of have to navigate through it and making sure that, you're in the right directory and so on. Most developers, they build stuff for Linux because you can test it in a lot of the releases as well. Okay, so once we have the memory profiler, which is step 9, we would then write our script. Okay, and there are several tools. You can use Vim, or you can use Nano, and Nano exists in Mac OS as well, and Mac OS also have terminal. So if you wanted to make a file directly in the command line, right, you can just call up Nano, and then you give it a name. We're going to call it line profile.py. So if you want to create a program called Hello World, you just say nano hello world.py, right? So now it knows that you are writing Python file, and Nano is a text editor. So Nano is equipped, right, with this release. So here you are. Now we're in the text editor. And so I'm going to go ahead and scroll down real quick so you can see. So I took a snippet off of my script here, right? And I'm using the examples the same as the documentation is provide. So at the top, I have a block comment. I just put the program for line-by-line memory profiling. And in this program, we are going to make 2 lists. The first list is going to be A, and the second list is going to be B. A is going to contain some mathematical operations, and B is also containing some numerical value and math operators. Then it's going to compute that. Then after that, we are going to delete the list B. And the reason why we wanted to see that is when you create container that stores data for your application, it's going to allocate memory space somewhere. So when it executes that task to make that container, it's gonna point that to that container to a location in the memory. Then after it created the containers, when it goes to and it's delete B, right? It's going to remove that container from that memory location, but it's still going to have to execute the deletion. So deletion is going to when you're also going to see the impact on the RAM. And then we want to return A, And the last statement on the bottom is just going to be your main. So say if the namespace is main, right, it's going to be calling on mem line, which comes from our, it comes from the profiler. Now, important that I didn't mention that there's a decorator on top. So when you use line by line profiling or memory profiling, when you're doing that, you make sure that you are using the decorator. Okay. So let's do that. And I think I already have, oh no, it's in a different directory. So we would start with profile, decorator, and then we can define mem line. This is our function that we create. And then tap in, A is going to be list one. And we are going to operate 10. Oops. And B is going to be list two. And that's going to be 2 times 10, 7. And then we're going to delete B. We're going to return A. And then we have if double underscore name is main. Then we're going to call the function. Right? Just like how you learn in C++ or Java, you're going to call the function in main. Okay. And simple enough, right? So if you have other scripts that you want to run, as long as you put it in that working directory in your Python environment, like what we've seen in the Windows side, we paste in we copy and paste our Python file in there. And then we just execute the file, or we run the file, and it's going to be able to evaluate and give us the profile. So now we're doing directly in text editor in Linux. So we're using Nano. Now I need to save it. So you're going to hit Control X. Basically, Control X is a quit command for Nano for text editor. And it's going to ask you, do you want to save? Sure. So you're going to press Y and then press enter. So we already have our Python file that we want to test for memory profiling. Then we are going to run it next. So as long as you have the decorator, right? Like the app profile, like what we added at the top, you can use Python 3, and then you would use the module that you install, memory profiler, and then the file that you created, the script file. So what it will do is it will give you, sorry, the font is kind of large. I wanted you to see what I'm typing, but at the same time, it's cutting off some of the stuff on the right. But it's going to give you each line, and it's going to tell you the size of the memory that's used. So out of this, right, the largest one that you would see is going to be B. And then when it deletes B, it's going to give that back. So it subtracts that here. Okay. And then when it returns A, return statement, it's going to use up, right? Originally, A had 26.180. And then when it returns, it was 26.230. And it didn't increment anything. Before it went from 26 and then it increments 7.7. So this tells you information about your RAM usage line by line. So once you have that, for step 13, you execute that, it's going to give you the output. You just take a screen capture. And I'm running Windows on the outside, so I can just use the command to do the screen capture, or I can use snippet to the little scissor to cut the part of the screen and paste it into a Word document. So this lab, we only need to do some screen captures and that's all. So I want you to be exposed to how you would be able to do this in different systems, Windows system and also Linux system for the chapter. I did want it to do IPython and then on the Linux side. So, but you know, the exercises were getting kind of long because if you start with creating virtual machine, that can take a while. So we'll come back to other exercises down the line and we'll use IPython. Okay. Question. So once you have the profile, what you can do is you can also, you know, you can use it for other purposes. But the second part of this, I want you to show you how you can do it. So first we had used the module, but how you can do it with an import statement. So you can go in and you can edit your file, and what you're going to do is you're going to add, right, the line above your decorator. You are going to go ahead and put in the module that you're using, which is memory profiler, and you're going to import profile. And here you can set the precision. Basically, it will be the number of times that you want it to be evaluated. So the parameter would then be ignored if the profiler is used in command line. So if you do Python-m memory profiler, it's going to ignore the parameter here. But if you just run the file, right, it's going to utilize that parameter. So that's the true difference. So earlier, the step prior to this, what we did was we used the command in command line to access the profile of that particular script. Now in this one, we're just going to make a file using the import statement. We're going to set the position and we're going to execute. We're going to run that file. It's still going to give you the memory profile, but it's just a different approach where one is slightly different than the other in the background. Okay. So we are going to go ahead and come back to the actual script. So we can say, and you can up arrow this to nano line profile.py. And when you use up arrow, just repeating the command or the prior command. So here's my program after I run that command. And I'm going to go ahead and bring the decorator down. And I'm going to move my cursor up using the arrow key. And I'm just going to type in the import statement. And then I'm going to go down to the decorator and I'm going to set position. So precision is going to be 4. So it's important that we can narrow down on how we want the data to look. And so now I'm done. So I'm going to go ahead and hit Control and X, and we are going to save and press enter. So once you edited your file, then you can run it using the step 17, which is we just use a Python 3 command. That means that we're using Python to execute this file. So there we go. The difference in this output is, you notice your decimal points is now 4 because you set the precision to 4. So if you want like longer decimal points, then you can just set the value there, but you cannot use the command memory profiler. You just have to run it as a file, but use the import statement. Okay. Now we can also output this to a file, and then we would use that file to be able to either visualize or report and so on. And keep in mind that this program that we wrote is minimal, right? It has a few lines. So in a more lengthy program, you would see a longer list, and it's going to give you the analysis of your memory usage. Question. So once you have that, take a screen capture. Then we can move on to the next step. Any questions? And if you compare this one to the last result that we got, it's slightly different, right? Earlier we saw that the increment for A was 7.7, but it starts at 26. Here we would see the 24.7, and then the B got a little bit bigger. And then when it removed, it subtract the value for list B once it's deleted, and so on. So there's some slight difference from one result to the next. And so with that, we had finished up to step 18. And so I want to touch on like the majority of the areas from the chapter with this exercise. So you can see, we already did C profile with Windows last time, but you know, you can also run C profile on Linux OS as well. So now what we're going to do is we are going to do some memory usage reporting, and we are going to look at time-based. So this section is focused on time-based profiling, and it's going to give us the usage report that would be external process. So if you run anything that's executable that would use memory in the current directory, you can get a general idea of how much RAM it's using. So if you ever look at like task manager or performance monitor type of interface, right? It tells you how much RAM each process is. It's very much like that. So we can evaluate our application on how it's using when it's executing, when you're running a certain executable. And all you have to do is you just need to include the executable following the mprof, which is memory profile, and the run command, and then your file or your executable. Okay. So my mind automatically went to like Rootkit and things like that for malware. You know, in the case that if somebody is testing this and see how much resource it's using when it started impacting. So Rootkit, malware, they're all just scripts, right? They're all programs that utilize resources or just take over some of the resources on your system. So in such case, if you're looking at those type of malware, what can we do? Well, if you are studying it, you would then need to really profile how much RAM it's using, what type of resources it's doing. We can map out, you know, the type of functions that it has and so on in the back. And that's all very interesting, right? So here, now we're going to start doing, I don't know why I put step 19 there. That's just general information, but it was really late and I was tired. So we're going to start doing step 20. So we're going to do M profile, then run, and then our file, line profile dot py. Okay. And here you are, you also have additional details on memory. It's going to look very similar to the last one, right? And you also get slightly different result, but it's still going to give you the details for each of the lines. So these are different ways, and this part right here now is it's time-based. So there's a component of time when you're using mprof in this case compared to the last one. It's not line by line. Okay. So it's gonna run it based on the time that's allocated that it would complete a specific task in that program. And if you want, you can edit the program and remove, you know, some of the statement, the top statement, and see with just the decorator how it's going to look. Okay. Any question with that short little section? There are more. You can actually do a graph, and you just have to install matplotlib with it, and then be able to do that. Last night I was working on it, and then I don't know what happened. I just like, for some reason, it did not want to graph things out, and I think it's just because I didn't have the sub part of matplotlib added. So I ended up not pursuing the graph part, but you can definitely graph it out. So if you have a lot of the details from your report, it allows you to visualize it. So instead of the run here, you can do a mprof graph, and then you can execute it. If you already have a profile created, it should be able to use the content of that profile, and you can plot it. Okay. Any question? All right. For the next one, we are going to look at time it module, and this is Linux only or Unix-based system. This is for bytecode, and it's gonna, the way that we do it is we are gonna use, we can use command line and we can actually run it with the file. So what I wanted to show you is at the simplest level, you can take the expression from your program and you can plug it in, and then you just tell it to provide you the result for each of the expression. Okay. And this is a loop, right? It's a for range. So you can see how it would react, how it works with the loop. Okay. So you don't have to install anything for this one. Sorry, my Zoom is always in the way here. Okay. So we are going to execute step 22, which is Python 3 -m, and we're going to use time it. And this one is a single quotation, double quotation, dash, double quotation, dot, join. Okay, string for n in range 100, single quotation. So what it's going to tell you here is this is the amount of loops that it ran. The best out of 5 is going to be 14.1, okay, per loop. It's using microseconds. So you can test your statement. So also this way, especially the iteration for your program, your loops. And then what we're gonna do is we are gonna mostly change up. We're gonna add a square bracket there. And we're gonna add a square bracket in front of the string. I'm gonna execute it. And so by doing that, you can see that it is now 12.2 for the best. Okay. And then we're gonna take out the square bracket there, which is a list. And then we're going to add another brace in here. And we're going to add, instead of the 4, it's actually join, and then let's take this out. We're going to pass the string inside the parameter this time. And that changes to be higher value for the best of 5. And that's only 10,000 instead of 20,000 loops. Okay. So if you want more information, I put the link here for time it. You can check that out. Okay.
Excuse me?
Yes.
Why did it change from 20 to 10,000 loops?
So for this, we're only going to map the string. So instead of using the string, right, as how you would pass it is going to be different. So when you use it inside the parameter, it actually reduced that. Instead of iterate through the string 2, it's going to be half of the size of the iteration that it tests. Because when it's on the outside, it's going to be applying the string with the actual full range. So it's 20,000 versus 10,000. So, and then the second time we actually treat it as a list, right? So, and then on this one, we treat it as a, it's still going to be in the same container, but compare this to this, you're using a map, and map is going to reduce it. So string becomes part of the parameter in the range of 100. So it's less because you're not sending it through the for loop. Both of the others, it's 20,000. It's because you use a for loop for iteration. Other questions? So on theirs, this is the example from the documentation, right? On theirs, it actually loops the same. Okay. And then on mine, it loops. The first time is 20,000, the second time is 20,000, and the third time is 10,000. And I believe that it has to do with how you putting it into the parameter. So it's actually a container inside the container. And when it maps it, it loops less in order to be able to produce. But in that sense, you would see that the time of it is changed. So as you run it again, you're going to see it's different again. So you would want to do this many times in order to get more of a conclusive idea on what, is it going to be faster or slower, or and so on. I don't know if you know Tim Peters, right? He's the other creator for Python, like CPython, and he did some work with IPython. He wrote a book called Python Cookbook. And, there are great chapters, so you should check out some of the content from his textbook and be able to do that. Okay. To see learn a little bit more about how to improve your program. And then if you want to make it, if you can run this in Python, right? Like you call up, so you can say Python 3, and then the first statement would be import time it. And then you can just write each of the statements. So you would say time it, and then you would use you just tell it how long, how many loops that you want it to go for. And then it'll tell you the time. So that's how you can run it in Python. And then you can also use Lambda. So here, oops, sorry. So the timer instance, all that is going to be able to run it using the time it module. But here's the parameter. You wanted the pass, you wanted to be able to do the statement, the setup, the timer or the default timer, and then the number. So you can actually specify, Michelle, you don't have to make, you don't by default, it's going to run as many times, but you can specify the number of loops that you want it to go.
No, I was just wondering because it didn't change for me. It just kept it at 20,000.
Yeah, and so for me, it actually reduced it down to 10,000, and I think it just varies based on processor and also RAM on the system. So there are some dependency in hardware, in my opinion, when you're looking at this. But to be more consistent, you can actually use something like this. You can specify how long.
So based on my question from the other day, is 20,000 loops better than 10,000 loops?
Yeah. So the more iteration that you have, the closer that you're going to get to the margin of error, right? The delta. So you want it to go, so that's the first time I run, and then maybe, maybe I would run it again to really test it the second time, the 20,000 loops from the second time to the first time, and what is the variance in that. So statistically, you can actually take a look at how it's going to be different across. Okay, and there are other methods that you can use with time it. So I suggest looking at the documentation. All right, so that's a little piece for time it, because in the book they talk about using magic command and all of that in Python. I felt like it was a little bit harder, so the best way is to go to the documentation and see how they test it, and then you can use it and see how you can work it. So if you take a statement from your program, right, you can a loop that you want to run, you can check that out. All right, so we did the KDE for this part. So we're going to use CallGrind and KCacheGrind. If you look at their information page, it's just generally telling you what it is. And then there is a quick guide, which is always helpful when you start learning about the tool. Okay, like installation and how you can install it. And it tells you that you need to use KDE 3.x or higher. Okay, so that means that you have to use KDE desktop on Linux. It is also, the packages should also be installed. So if you wanted to graph it, then you need to do GraphViz. And those of you who took 30B, we did a little bit of exercise on GraphViz. But all that is going to create, little shapes, and that represents a map for your resource usage. GraphViz can be used to do diagrams or network maps or lots of things. So it tells you here that you would need to use the bin utils and the GraphViz. Okay. All right. So if you wanted to look at their documentation, it also shows you how you can use GUI and how to visualize and so on. So that's the tool that we're going to be using. And CallGrind and KCacheGrind. KCacheGrind does not access the file, the report file directly. And CallGrind uses runtime instrument called Valgrind, and that Valgrind is the framework. And while they're sharing the library, there are separate plugins. So just like how we talk about PyTest is a framework, and then you would need to plug in like, the benchmark and other type of plugins to see more details. So the data files are generated by CallGrind, and then it's going to be loaded to KCacheGrind so you can see the performance. Okay, but KCacheGrind uses another tool called PyProf to call tree. What a name, right? To really give you the visual. So we would start with installing KCacheGrind. So you would do sudo apt-get install KCacheGrind. And then you simply put in the password. Okay. And then one of the things that it needs access is C profile. And earlier in the chapter, we talked about PyTest and C profile. So the way that you install C profile in Ubuntu is you would use a pip3 install C profile V. Oh, I mistyped again, sorry. Okay, and then once that's installed, we gotta bring in another package called pyprop2 called tree. And that tool is going to give us the visualization of the result. So now once you have all the tools installed, all the module installed, you would issue, so this is similar to what you've seen in the Windows exercise that we did. So you would do a Python 3-m C profile output the file called prof.out line profile py, okay, which is the script that we wrote. Sorry, let me move my Microsoft document up. This up so I can see. Okay. So now this gives us the profile using C profiler, right? That's a different tool from what you've seen earlier, which is line by line profiler or memory profiler, and then time-based profiler. Why is it showing you very close result? Well, because it's the same program that we're using, right? Which has the same functions, the same task. But in order to visualize, you have to build a C profiler. And then after that, we are going to use the pyprop2 call tree to give us the visual. So step 28. And then we're going to do a output a file and output it to call tree. So it will convert it, the profile that you created previously, to a call tree file. And then you are going to use KCacheGrind call tree file that you just made. Or we would use KCacheGrind. Boom, there you go. So these are just the tips. We can close it. You can read it if you want. And then there you have it. So in order to give you the visual, what we created in C profile, we have to convert it to the call tree file, and then we would use the call tree file with the KCacheGrind in order to see the output in graphical user interface. And it uses KDE desktop. Okay. So if you were stuck on the Windows side, you have no luck doing the PyTest, you can try to attempt it on Linux. Remember that there are some slight difference in how the commands are used, but you already installed the C profile on Linux as part of the last piece to do the KCacheGrind. So, okay, question.
Is there a specific graph?
Yeah, you can actually graph it if you install. I did not install GraphViz on this. I ran out of storage, actually, Michelle. I was working on, there were supposed to be like 5 more steps, but as I started doing it, the more visual that it gets, the more storage that it needed, and it gave me it gave me an error. It tells me that my virtual machine is not able to handle it. So I didn't want you guys to have to troubleshoot the virtual machine itself, but yeah, so you can install GraphViz on yours, and then you can try to do mprof graph, which also graphs it out. There are, I put here that you can use a thing called profile viewer, which is what I was starting to write the instruction for. And if you read, it's really interesting. It actually maps things out. So you need to install it, right? And then make sure that you look at the dependent packages. And since you already created the C profile, you just got to give it an output name like what we did with the prof.out. And then you go through and it would look like that. I think the book shows a little bit of this, but this is another way that you can look at the profile visually. And it gives you the statistic. Okay. So, question. Now this stuff, the more you use it, I think the more you're going to be familiar with it. And then you can install Malay. And in that, it also gives you a different visual as it scans it. So instead of looking at container inside container, it actually maps everything out. Looking at your globals and your local and so on. All your objects, which are containers. Okay, so check that out and you can see how you can go about trying it. Question. Anybody have challenges with virtual machines? Well, on the bright side is that it works. That's my goal. That's the first part in design, that get things to work, and then you can always improve it. So the next time that, I implemented a lab like this, I just want to make sure that, it's going to get a little better and a little better. And eventually, but you get the idea of little pieces of what the authors were talking about. You get to experience it hands-on. I hope that, it gives you a better understanding on how to design your applications, not in just Python, but overall. When trying to launch the VM after extracting the zip after KUbuntu logo, I get a black screen. Okay, so let me shut mine down and I'll walk you through the process. So give me a second. And then before you shut down your virtual machine, if you already use your virtual environment, okay, let me show you. Remember to deactivate. Okay. Oh, deactivate. And then you can do shut down now. Because if you type shut down, Linux is going to count down 60 seconds or something like that, right? Okay, so if you wanted to, after you extract, right, look in your folder. It should have the blue file, that's what you need, and then the image. So you're going to navigate and use the VDI. Okay, and you can always change the view to details. Okay, that's a VBox file. So let's close this guy out and start from scratch. So what you do is you go Virtualbox and then you click here. Go normal start. Oh, I'm sorry, click tools. I apologize. Add, and then go to where you keep your virtual machines. And then find the Virtualbox file, click open. It's already starting, so it's not going to open. Yeah, I have it running right here. Okay, so it should launch. So click tools and then add and then find that. So I suggest, Kevin, close your application or get out of it and then reopen it again. Also, when you have something that's open, like that same virtual machine running, it's not going to work. So Alex said same. It might be loading. Yeah, you have to give it like a little bit of time. But on the left side, you should see that it's selected. It should say Ubuntu. Okay. I tested this on separate laptop. Like I literally downloaded, unzip it on my other laptop, and then I run it to make sure that it works before I actually publish the assignment. So if you extract it and all the files are intact, it should be, yeah. So you might want to wait because it might show black for a little bit and KUbuntu would start loading. So it takes a minute to go. Or you can always make your virtual machine. That's why the instructions are there. So if it doesn't work, you can make your own. And then you just have to go through those steps, installing it and then adding the KDE. Okay, so if things right, so here it would show me all the ones that I've been using. And if it's not on this list, and you can always clear it, right? So if you wanted to get rid of it, you can move it, you can clear it. You can right click it. So if you want to remove it, you click remove. You want to start it, you can click start. If it's not there, you just click this and you click add. And you find it. Any question? Yeah, the KUbuntu logo, it takes a while. So give it some time, because if you, okay, so another thing that I also forgot to say is you can also change your machine setting. I think I mentioned this in the other class, but so here's the allocated RAM and stuff for it that we used when we installed it. But you can also change the system. So if you wanted to beef it up, right, you can also modify it before you start it, because it won't let you do it while you're in it. So you can go to settings, and then you go to storage, and then I'm sorry, there should be like where was it? Yeah, under system. VBox is a little different. So before you start it, if you wanted to beef up the RAM on it, like higher than 2 gigs, you just take this and you change the glider. Okay, or you type it in here. Now it all depends on how much RAM you have on your system. So if it's like running close, it might be a little slow to start also, because your system needs to source the RAM for the host OS, which is, you know, could be Windows, and then also the virtual machine. Okay, and again, if you wanted to change that, it's under setting, and then you can change it before. VBox had come a long way. It was really clunky before, but I think it's much better now. So the newer additions. So how is that coming along? It's still hanging? Okay. So I would check how much RAM you have on your system. It's using 2 gigs. And also, Kevin, if you download it and put it on a flash drive, if it's a USB 2, I found that it was slow for me. I had put it on a storage that uses USB 3. It's slightly faster, because the way USB works is it's still going to have to go through the main host system in order to read it. So it would be faster if it's on the actual local hard drive or the SSD, compared to if it's on like a flash drive. So if you're running it on an external drive, that could also be the reason. I had such a hard time with the external drives yesterday for both the version that I gave you and the version that I created with KUbuntu from the start. It was just slow to load, it was slow to write, you know, in general. So VMware is a little better at that, accessing from external components. It's just the way that they design the software. So I felt like VMware is a better tool if you're using external storage compared to VBox. VBox is really designed to use on your local drives. Okay. And there are Zen and other too. So the two that we talked about are just the mainstream one that you see. Okay, questions, other questions? Okay, I'm gonna stop recording.